So now we have seen earlier the results for shifting properties, correct? F of k plus n for causal sequence and so on. So that only we are going to do it here. So let us start with this. Let us start with this. So the standard results which we are going to use it here, standard result, and we are taking always for causal sequence only. So for causal sequence f of k for k positive, So Z transform on f of k is nothing but f of z, correct? So Z transform on f of k plus 1, f of k plus 1. See, if you see that property, the third one, shifting property, third subcase, we are using that. So it is nothing but z times fz, z raised to n fz, n is 1 here, minus you have to just take the values from r is equal to 1. So that you have to subtract, correct? So it is r equal to 0 only. So we'll have to take that as z times f of 0. Then z transform on f of k plus 2. F of k plus 2. You'll start with z square fz and then subtract the terms here. Okay. So it is z raised to n. So z square f of 0 minus z times f of 1. Similarly, you can write it down z transform on f of k plus 3. It will be what? It is z cube fz minus z cube f of 0 minus z square f of 1 minus z times f of 2, and so on and so on. So you can see that once you write it down the formula for f of k plus 3, you will understand this, correct? How to write it down this by using shifting property. So you can remember it very easily. Similarly, we have seen Z transform on f of k minus 1 for the causal sequence, and that we know that it is Z raised to minus 1 fz, correct? Or Z transform on f of k minus 2, that also we have seen, and that is nothing but Z raised to minus 2 fz, because the rest all the terms are in the sequence are 0, so that value is comes out to be 0, correct? Now with this, let us see how to solve this difference equation by using this. All of you have taken down all the formulas. Then we take one example based on this. Okay, these are the important formulas, actually results, which you have to remember to solve the difference equation. So let us take the example. Let us take the example. The example is obtain f of k. Obtain f of k given that f of k plus 1 plus half times f of k is equal to half raised to k for it is given k greater than equal to 0 and f of 0 is 0. Okay, k greater than 0 and f of 0 is 0. So this is difference equation which is written in terms of f of k and f of k plus 1. Now we want to solve this equation. To solve this, we are operating the Z transform first on both sides. And you can see here that the sequence is a causal sequence, correct? It's a causal sequence. So the first task is apply Z transform on both sides. Apply Z transform on both sides. So what do you get this as? So Z transform on f of k plus 1. You can write it down this way also. Plus half times Z transform on f of k is equal to Z transform on half raised to k. Correct? So what is Z transform on f of k plus 1? Just now we have seen the formula. You have to use that. So what we have seen that it is, see, f of k plus 1, it is z times fz. So the power of the starting power is same. Okay, and you have to end till z raised to 1. You can see here. And all the remaining signs are minus. You can see that the power of this and this first term is same. Only thing is this is transformed one and this is the sequence value. Okay, so this is capital F and rest all of them are nothing but the small f, that is sequence values. Correct? So we'll start with this. We'll write it down the formula here. So it is what? ZFZ minus Z times f of 0. Correct? This is the answer for the first one. Second is half times what is Z transform on Fk? It is Fz. And for the causal sequence, we have seen that when k is positive, what is Z transform on a raised to k? It is Z upon Z minus a. Correct? With mod Z greater than mod a. So it is what? It is Z upon Z minus half for mod Z greater than half. Correct? Now what is given? Given here, given f of 0 is 0. So substitute it. Substituting, we get. So this is the initial condition is given. So you put that condition, so we can write it down this as ZFZ. And this value is 0 only. Plus half times f of z is equal to, I just keep that z minus half as it is. One can make it as 2z minus 1, but then that will be little bit difficult later on. Okay, later on. So what we can do is, we can just rewrite this as, see, this is nothing but you can take out from this f of z common, correct? So I get this as z plus half times fz is equal to z upon z minus half. Now what this will give you? This gives f of z to me, that is transformed function, which is what? Z upon z plus half into z minus half. Correct? So this is the half part. We have gone with the half part. We are through with half part first. Okay, so first thing is what? You find it out f of z. That is our first task. That's our first task. Once we do that, what we have to do? We have to operate now the inverse z transform. Correct? Now apply the inverse z transform. Up to this, everyone has understood. Are you all following this? The first task is, whichever the expression is given to you, the relation is given to you, you apply z transform on that and substitute the initial conditions which are provided it to you and find it out f of z in terms of z. find out f of z in terms of z. Now we'll apply inverse Z transform to this. So what is our f of z? F of z is z upon z plus half into z minus half. Now apply inverse Z transform on both sides. Now here I forgot to write mod z is greater than half on both sides. So what we get this as? So we can write it down this as inverse Z transform on this, but then what I do is I'll apply in this case this partial fraction method. So you can now use any method, whichever you like. Even if you want, you can use the inversion integral method also. Okay. I'll solve this by using partial fraction method. So for partial fraction, what I have to do, I have to take this 1 upon z plus half into z minus half, which is a upon z plus half plus b upon z minus half. To solve this, it is 1 into a times z minus half plus b times z plus half. Put z is equal to half. So we get b is equal to 1. Correct. Put z is equal to minus half. So we get a is equal to minus 1. Without this also you can make the adjustment and you can add this coefficients. Correct. Here it is possible actually. Okay. So f of z by z is what? It is minus 1 upon z plus half plus 1 upon z minus half. Now I just take that z on the other side. So f z can be written as z upon minus z upon z plus half and plus z upon z minus half. Now what is given? The given thing is region of convergence here is mod z greater than mod of half. Correct? Or because see, you can see here that this concept will come with mod z greater than half. So how you get half? I can write mod z greater than mod of minus half, or I can say that mod z is greater than mod of plus half. And we are having both the situations here, correct? So for both the cases, it is same. It's same. Okay. Mod of minus is also positive only. Correct. So here what we do is the region of convergence is mod z greater than mod a. Correct. Region of convergence is mod z greater than mod a, and for that what we get? We get the value as for z upon z minus a as a raised to k. Correct. Inverse Z transform is what? A raised to k. So this can be written as, so when I use the inverse Z transform, you can see that this f of k is equal to, f of k is equal to what I get? Minus of z minus a. So it is minus half raised to k plus half raised to k for k positive. Okay. So what we get the result as, the answer as, so here the solution is nothing but it will be minus of inside the bracket minus of half raised to k and plus half raised to k. Correct. If you want, you can take this minus 1 raised to k and this minus sign. So it will be minus 1 raised to k plus 1, like that also you can write. But then it is not required. It's not required here. Okay. So see, this way you can find it out the answer. You can find it out the answer, and that's very easy to solve the questions with this Z transform. Correct? So whenever the difference equations are provided to you, then in that case, what you are supposed to do is you will just apply the Z transform, use those initial conditions, find out f of z here. Once you get f of z, then you have to apply the inverse Z transform. So you can use either partial fraction method or you can use the inversion integral method also. Whichever you like, that method you can use. Okay. And that way you can get the answer of such kind of questions. Such kind of questions. Now let me give you one more question. Okay. Done with this? Okay. So take the next question. Take the next question. And you tell me the answer also. Okay. So the example is obtain f of k. Obtain f of k with given that f of k plus 2 minus 4 times f of k is equal to 0. See, on the right hand side the function is 0. So that's very simple to do. No? F of 0 is 0 and f of 1 is 2. F of 1 is 2. Now how you will solve this? So for solving this, you apply first of all Z transform on both sides, correct? So I just take Z transform on f of k plus 2 minus 4 times Z transform on f of k. And what is Z transform on 0? It's 0 only. What is Z transform on f of k plus 2? So that is Z square f z. It will start with Z square minus Z square f of 0 minus Z times f of 1 minus 4 times f of z, correct, is equal to 0. What is f of 0 given? So substitute here, substituting f of 0 is 0 and f of 1 is 2. f of 1 is 2. So we get z square f z. F of 0 is 0 only. So this term is 0 minus 2z minus 4fz is equal to 0. So what we get this as? So it is z square minus 4 times f of z is equal to 2z. Correct? So this will imply fz is nothing but 2z upon z square minus 4, which I can write it as z plus 2 into z minus 2. Correct? Z square minus 4 in the denominator, you can write it as z plus 2 into z minus 2. And then just use the partial fraction method. So here itself you can make the adjustment for this terms. Correct? So f of z by z. Correct? Is 2 upon. I just take that 2 also on this side. Correct? 2 I'll take it out. And then we have z plus 2. And here we have z minus 2. Correct? With plus sign. So here you can have this as, even we can adjust here too, no? That will be 4. So this will be z minus 2. So we take minus 1 times this, correct? Minus 1 upon this. And here it will be what? Minus 1 by this. And this will be 1 upon. So what I get here actually? Z plus 2 into, that will be plus 2 plus 2. So plus 4. 4 we get, no? Correct? So I have to adjust that 4. Correct? So we get this as, so this is the adjustment. You will get the same answer when you do it by using your usual way. Yes, I think everyone is agree with this. So this can be written as, so using applying inverse Z transform. So we get f of k is equal to half times. This is, see, when we are writing it like this, the transform. So here it is, of course, mod z is greater than 2 is given, correct? So for that, and it's a causal sequence because the values are defined from 0 onwards. So that is for causal sequence, correct? So assuming that mod z greater than 2 here, because it's not given, so you have to take it on your own, okay? And then we have minus of, this will be minus 2 raised to k plus 2 raised to k. So we get the result as half times, it is 2 to the power k minus of minus 2 raised to k for k positive. K positive. Okay. So this way you will get the answer, and see, it's very simple to do it. Very simple to do it. So I'll give you some more problems to solve. Okay. So let us take those problems which are there to solve. Take the examples and solve those examples. I'll give you the answers also for that. So the homework exercise. Okay. So everywhere you have to obtain f of k. Number 1, 12 times f of k plus 2 minus 7 times f of k plus 1 plus f of k is equal to 0, 0. For k positive, f of 0 is equal to 0 and f of 1 is equal to 3. The answer is 36 times 1 by 3 raised to k minus 1 by 4 raised to k for k positive. Then the next question is f of k minus 4 times f of k minus 2 is equal to uk for k positive. Now it is like u of k. Okay. uk means u of k for k positive. So in this case, what you have to do is you have to just take unit step function, discrete unit step function for k positive, and that way you have to solve. But here they have given you k. Okay, so let me take it in a different way. Just add some different thing here. Okay. So you can take it as one problem because here no condition is required, as this is z raised to minus 2 only. Okay. So no condition is required to solve this. The another question you can take it the same way. F of k minus 4 times f of k minus 2 is equal to half raised to k. And here we have the answer for this. Answer is 2 by 3 into 2 raised to k plus 2 by 5 minus 2 raised to k minus 1 by 15 half raised to k. Okay, positive. That way you'll get the answer. Then fourth problem is f of k minus 5 by 6 times f of k minus 1 plus 1 by 6 times f of k minus 2 is equal to half raised to k. Okay, positive. So again, you have here k minus 1 and k minus 2. When you operate z transform, you get z raised to minus 1 fz. Here, what you get this as? It will be z raised to minus 2 fz, correct? And then you take it in the denominator, f of z by z square, like that, and get the things done. So that becomes easy only, but the answer is different here, okay? Because we have to take the values it in that form. So it is 4 times 1 by 3 raised to k minus 3 times half raised to k plus 3k half raised to k. So here we have k times a raised to k formula, correct? Which is already given in the your tabular forms, correct? So there it is there for k times a raised to k form. And when you get that, you will get that it is a z upon z minus a square, correct? If you remember that. So there we are using that multiplication by k rule. So this way there are ample of problems one can solve, one can write it down, all the relations there, okay? And you can attempt the problems. So with this, we have completed with the Z transform. And from Monday onwards, we are going to start with the Fourier transforms in the class. Correct? Today there are less students. Why it is so? Only 37. Hmm?
I think because of the summit.
Okay, so what will be the status for the tutorial today? Are you all will be there in the tutorial?
For today, there will be only inverse Z transform, right?
Yes, yes. And this also. This
Yeah.
problems will also be there. Hmm. So if you say I'll take it today or tomorrow, I'll post but the tutorial so that you can solve it and upload it like that. Okay. So tell me on our WhatsApp group. Hmm? Okay. So we'll
Yes, ma'am.
end this because we'll start new topic next time. Okay. So bye to everyone. I have already taken the attendance. If anybody want, they can also send me. It's not a problem. Chalo. So bye to everyone. Please tell me about the tube because many of them are messaging me that they are in summit, so they are not able to join the tutorial or something like that. Many things. Okay.
Yes, ma'am. Then I think we should keep it tomorrow.
Yes, ma'am.
Yes, ma'am, tomorrow, because
We
many
can
of
do it
them
tomorrow.
But you tell me the timings then tomorrow so that I'll post that time. You tell me your convenient time, huh? All of you.
Okay,
Ah,
ma'am,
yes,
we'll
ma'am.
decide and let you know.
हाँ चलेगा
Yes,
चलेगा.
ma'am.
Yes, no problem at all.
Okay.
चलो then. Okay, students. Bye.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Yeah.